Okay, welcome back again. This is the third session. Thank you for staying with it. If you're not with it, then what do I know about being with it? When you get to my age, you know nothing, or at least you know nothing, which is part of the battle, I reckon. Okay, so what makes a game? Last time, stories so far. Previously on this course. Sorry about that. Too much caffeine, too much caffeine. Programs tell computers what to do. You write a program using a programming language, which C# is one of. And so C# is this language what you use to write programs. XNA is built on top of that. Just scratched my head and banged the microphone. Sorry about that. XNA is this framework that provides program resources for writing games. And a program works on data, numbers and stuff, and performs actions on that. Okay, so your program says, we're going to use this data and we're going to actually do these things with it. That's what we learnt last time, and so now we're going to move on and push back the frontiers of knowledge even further, which can't be bad. Computer games are really a special kind of computer program that plays a game with us. If you didn't know that, then I'm surprised and, quite frankly, a little sad. But there you go. I've been called more than a little sad in my past, so there you go. Computer games programs all work in the same way. It doesn't really matter what the game is, and you can look at any game and regard it in this way. It starts off, you get the loading screen, which runs for a while as all the pictures, sounds and models and stuff are brought into memory and made ready for use. And then once the thing is going, pow, it updates the game world. It moves everything. If you're in a driving game, it moves your car. It moves the cars you're racing against. It does all that good stuff and actually makes sure that the world changes over time in the way you would expect. It also, as fast as it can, it draws the game world so that you see around you what you should see at that point in the game. And the drawing should reflect what the world looks like. So as cars get closer to you, they should get bigger and that kind of thing. And you do this flat out. And this is true whether it's Grand Theft Auto, Pac-Man or The Sims. All games work the same way. Bring in a bunch of content, use it to create a model of the world your game is implementing for you, and then draw it and update it as fast as you possibly can. And that's about it. And that's what computer games are all about. When you write a game program, you're writing a program that plays a game against somebody. Another thing to remember though, if you can write programs, you can write programs to do anything. So learning how to write games programs means you can write other programs as well. And in fact, my friends in the industry, yes, I have friends in the industry, not the games industry, just the industry. My friends in the games industry say that actually programmers that can write games are fairly sought after by general purpose employers because they know they're quite good programmers and they're actually able to create programs with nice user interfaces, because most computer games look pretty snazzy. I mean, that's the whole thing about a computer game, is that it should be fun and easy to use, and the theory I think extends to ordinary programs in that perhaps they should be fun and easy to use as well. Maybe one day they will be, but I'll be in the ground long before then, you know. Moving on. That's the silly voices, Miles. As far as we're concerned, here you go. This is what happens when you draw a program as a box with boxes in it. It contains the data, which is the stuff that the program works on, and not somebody in Star Trek. Ha 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 ha. And it contains a description of the actions. So as far as we're concerned, data could be things like, I want to make a cake, I'll need bread. No, not bread. I'll need flour, better. Like a bread cake, I suppose. Moving on. I need flour, eggs, butter, all that kind of stuff, and so those are effectively the things I'm going to be working on. And then the recipe, which is what to do to make the cake, is a set of actions you perform using those ingredients to make it. So if you're thinking in terms of mapping programs onto cooking, then as far as we're concerned, the ingredients are a bit like the data, and the actual recipe is a bit like the actions that the program performs. And any program is made up of these two things, okay? Stuff we think about and the things we do. If you get that. I'm not even sure I get that, and I'm supposed to know this stuff. Moving on. Okay, as far as an XNA game is concerned, you can take this box and add some other boxes inside. The actual data is data about the game world. It's stuff that describes what the world is. If it's a driving game, then the game data will contain the design of the track, the speed of your car, the location of your car, the setting of your throttle pedal, the setting on your steering wheel, how worn your tyres are, how fast your opponents are going. All that stuff is data about this racing car world. And then every now and then we update that data. All the cars move. If I'm pressing the throttle down, the car acceleration goes up. If I'm turning the steering wheel, the car goes round the corner. And so the update action updates the game world and effectively moves it on to the next step. If I'm playing a shoot 'em up game, then basically that'll move all the bullets and see if anybody's been hit with them. If I'm playing a puzzle game, it'll actually look to see if I've made the puzzle fit together or solved the problem or lined the pieces up or whatever. And it'll basically update the game world, whatever that world actually is. The draw behavior produces a view of the world for people to look at. So as far as draw is concerned, that's the thing that actually produces a picture on the screen. So it takes the game data and sort of makes it into a picture. Now, the picture you see depends on what the game's been told to do. If you're like in a map view, looking at the top-down view of the cars on the track, you'll see the entire track and the cars moving around it. If you're sitting in the car, then you'll see the view from the person sitting in the car looking out through the windscreen. So the idea here is that the draw behavior, its job is to, as quickly as it can, make a picture of the game world on the screen. And so these two actions are the fundamental ones. There are others in a game to do with things like fetching data off the disk and saving your high score and finding people on the network to play against and other kind of stuff like that. But fundamentally in a game, the two things you must have are an update action that moves the world along and a draw action that draws a picture of that world. Those are the two things that you need. And if you haven't got those, you haven't got a game. As far as XNA is concerned, these things are expressed in what are called methods. Now, a method is a lump of code in C# with a name. Okay? And that's it. You make a lump of behavior and you give it a name. And when you call that method, when you use the name, then it actually does that method. If I had a robot butler, oh, that would be great, wouldn't it? I would teach the robot butler how to make tea. And I would say, Robo Jeeves, and it would basically toddle up, make me a cup of tea. And because it knows how to do that, it would then go off and do that thing and bring me back a cup of tea. Same with draw and update. I take a bunch of C statements, commands to the computer to do stuff. I put them in a block and give them a name, and the name is, in this case, draw. And I say draw, and quick as a flash, the screen is drawn. Same is true for update. Now, when you start off, you get a template game, a brand new empty shiny game with empty draw and update methods, and the idea is that you go fill those in. And so making the game is as easy as they can possibly get it to be, because they give you everything except the last little bit you have to fill in. No starting from scratch, no scratching your head in terms of how do I get this thing to go. Straight from the off, you've actually got those methods and you can start to play with them. Now, what I will do now is really brave, in that I'm actually going to make a brand new empty game from scratch. And to do that, I have to get back to my desktop, which is actually proving quite hard to find. Here we are, desktop, nice clock. That photograph, by the way, was taken in Amsterdam airport of some seafood. Isn't it nice? And as you can see in Hull, it's 17 degrees and it's raining. That's basically a computer replacement for a thing called looking out of the window, and actually it lines up pretty well with what real life's doing at the moment. As far as we're concerned, to get things going, done this before, click on the start button, go and find Visual Studio C# Express, which has got XNA built into it, and at this point I've got all kinds of things go on, but what I can do is I can go new project, please, and I can ask myself for a Windows game, and I'll call this a bit of fun. Why not? Just a good name with any. Click on OK. Rattle, 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 bang, and eventually, when my cursor stops flashing because it must be nervous or something, I get my game. Dig a bit further down. Ooh, look, a method called update, which updates the screen, and a thing called a to-do, which is basically telling you you should really put some code in here because this is how your game will be made to work. So update, which updates my game, there it is. Draw, draws my game, there it is. And the thing I want you to pay attention to is this graphics device.clear that basically says there's this thing in the game called a graphics device, and it is the device that does the graphics. The clue with XNA is mostly in the name. Okay, it supports a behavior called clear, a method called clear, and I can give it a color to clear the screen to. In this case, XNA for some reason has a love affair with the color cornflower blue. So if I run this XNA game, the system will now build that XNA program and run it, and I have a cornflower blue screen with the title A Bit of Fun. Cute, eh? And I can stop this program by pressing the blue button that says don't run anymore, and at that point the program stops. So what I want to show here is that this draw and update behavior is tied into the way games work, and it's also tied into the way that XNA works, and it's also tied into the way that you make XNA programs. Okay, so we get a draw and an update, and what you'll find as you write games is that the time you spend programming, very large chunk of it will be spent putting code into those two methods, because they're the things that make your game work. They're the things the game actually springs from. Okay, so back to the presentation, if I can get there. Hello, on to the next one. So as far as we're concerned now, we know about draw and we know about update and we know a bit about methods. A statement is effectively the smallest thing you can ask a computer program to do. It's a little lump of behavior. If we're writing a recipe, we would say things like turn on oven, and the idea is you turn on oven, wait till it's reached temperature, put cake in oven, wait 3 hours, get cake out, eat cake, move on. Each of those little steps is a step in my cake building and perhaps eating program. And so as far as we're concerned, a statement is a single step. A method is a number of statements in a block which I've given a name, and a whole bunch of steps like boil the kettle or make a cake. Those are method names, because boil the kettle means pick the kettle up, fill it full of water, put it on the stand, turn the kettle on, wait for it to burn. That's the door. I'll be back, I promise. Hang on a second. Okay, sorry about that. That was my trousers and a couple of shirts. I've been buying clothes off the internet. It's what you do when you're writing stuff and you get bored. So a couple of trousers and a couple of pairs of shirts. I'm not wearing them at the moment, but next time I might be. Something to look forward to. Anyway, back to the plot. A statement is a single step in the program, like turn on the oven or whatever, and a method is a lump of statements you have a name for. Okay, like boil the kettle would be a whole bunch of steps. Sounds good to me. Okay, the draw method we've already seen, and it contains this clear thing. In fact, this is the only bit I really want to focus on. The to do is just a comment that effectively means this is a note to myself, and it gives me an action I need to perform at some time during the program development process. So it basically says, don't forget to put a drawing method in here, please, Rob. Otherwise, it won't do much. Okay, and so look at it in detail. The graphics device is the thing in the program that does the graphics. It has a clear method sticking out of it, which you can call to clear the screen. And clear is told what to do. And it's told what to do in terms of a parameter, which is a posh name for this is what I want you to do. And in this case, the thing it's being given is the color to draw, which is this kind of blue we've already seen, which is kind of cornflower blue, and I quite like. So that's what clear does. It's in a cooking program or a robot butler program, you'd have a method called make Rob a cup of tea, open bracket, white, comma, sugar, close bracket, say, and then your butler could go off and do the right thing. That's the kind of thing model we're talking about here. This thing is a lump of behavior which we tell what to do, and what you tell it depends on what it's going to do for you. That helps. If you look at a method call in terms of making sense of real life, back bedroom is the place that holds items, satellite TV is the place where the satellite TV lives, switch channel is the method I want to use, and then the thing I wanted to do is turn to BBC One. That's what I would tell my robot butler, to go and turn the TV in the back bedroom onto BBC, please. And you can see it's really just a question of breaking down the instruction into the thing which, oh, that was a text message, oh, jolly good. Everything's happening today. And so this is just like we would tell people, go and turn on the TV in the front room, or make me a cup of tea, use the third cup on the left. I mean, this kind of stuff is how we phrase things, and programs take that through in terms of how they express things as well. I can use the same framework to actually call through and get myself a different color. The graphics device is the same, the clear method is the same. I want a red screen now. I quite like yellow, so what I'll do now is show you how to make a yellow screen out of my program. So here we go. This is where I was last time we did this, and these are my lines of C#, and down here we've got color.cornflower blue, and if I want to I can just get rid of that and go color, and then I'm going to go and this. One of the nice things about C# is it binds very closely with Visual Studio, which is the environment you use to write the code. And so what I can do here is I can actually find my way to yellow, and it'll suggest the names that it thinks make sense. If I run the program now, because I've asked for a yellow screen, A Bit of Fun gives me exactly that. So there we are. Stop the program because yellow's fair enough, but I can sort of work my way through the various colours at this point. So looking at this, one of the things I've always wondered, there's a colour which Microsoft keep mentioning called teal. Let's see what colour teal is. Okay, so you run the program. It's kind of boring really. But there you go. If you've ever wondered what teal looks like, that's what teal looks like. Okay, right, so back to the presentation. We've seen a yellow screen. That's the wrong button. There you go. And so now we can move on. So what we know so far, what we've learned today: a program contains data and actions. It's very important you get this. Stuff to think about and stuff to do with it. As far as the game is concerned, the two actions we're most concerned with at the moment is draw and update. These are the things that draw the screen and the things that update the game world. When you make a brand new shiny XNA game, you get a draw method for free, and it draws a blue screen by calling the clear method on the graphics device that looks after the screen. And if you want to, you can tell it to use different colours, and different colours will appear as though by magic. And what I want to do now is move to the next slide, please. True and false time. XNA games not use data. That is so... Oh, look what are you doing? No, that's not good. That's so wrong. XNA games do use data. That's red, that's bad. Everything in a computer, pretty much all programs you're ever going to write, all use data. Next one. Method is a block of code with a name. Now I like that. That's got a lot of legs for me, and legs is good. So yes, that's just what a method is. It's a bunch of behaviors and a name you give it. Your program must call the draw method. Must it? No. XNA does that 60 times a second. You don't have to worry about getting it called. It just happens as though by some kind of magic. The C# language contains a clear method. Actually, no. Who does? Well, the thing that does the clearing is the thing that needs to clear, which in this case is the graphics device, because that is the thing that's looking after the screen. That's going to be red then, isn't it? The clear method is told the colour. Now we've done this. We asked for yellow. We even found out what teal is. In fact, I'll blow one of my questions away. That's going to be green. And yes, there is a colour called teal. And yes, I've got my second text message of the day. So I'm very, very happy that will go green. Okay, thank you very much for paying attention. Bit more writing games with C#. Sorry about the introductions. Don't do these things in the morning, Rob, and don't do them when the postman's due to call. I'm going to go off now and try on my trousers. Nice. I will see you all next time.